Hi, this is going to be a short video, and it's really just to teach the skill of how to simplify square roots or simplify radical expressions. And I just want to very briefly kind of talk about some of the principles behind this. So let's think back to the principles of exponents that we know. Like I know that if I have x to the second power, and then I raise that to the third power, that means what I actually have is x to the sixth power, because it's three groups of two x's. I multiply these exponents, right? So when I have a power of a power, I'm supposed to multiply the exponents. So, okay, so how does that relate? Well, what if instead I had, I had written it like this: x to the second power, and we've never looked at these before, but then I said to the 1/2 power, right? So what I really want to talk about is, what do fraction powers do? Well, if we're supposed to multiply the exponents, 2 times 1/2 is 1, so this would actually just, if I took x to the second to the 1/2 power, I just have x. But I also know that if I have x to the second and I want to get rid of that, I would just use the square root. So these two things are equal to, or are equivalent. You can use a 1/2 power the same way that you use a square root symbol. 1/2 power is the same as the square root. And so what that means is we can use the rules of exponents on square root expressions as well. So take a different example we're going to look at in a moment. What if I want to, just represent the square root of 72, which is an irrational number? I could represent it in lots of different ways. And there's one specific way we're going to look at in a moment. But you know that the number 72 is, for instance, you can write it as 12 times 6. Okay, so I just rewrote the number 72 as 12 times 6, because those two factors are multiplied together make 72, which means that I could also represent that as 12 times 6 to the 1/2 power. And then we also know from the rules of exponents that I can apply this 1/2 power to each of those factors. So that's like 12 to the 1/2 power times 6 to the 1/2 power. And remember that the 1/2 power is just the square root. So all of this is to show you that the square root of 12 times the square root of 6 equals the square root of 72, the same way that 12 times 6 equals 72. You can take a square root and you can split it into two different square roots, as long as the numbers under the root symbol, right, are factors of this number here, that they multiply to make that number. Then those square roots will multiply to make that number. So now it comes time to actually use this to simplify square roots. So there's really just two steps here. But the reason that 12 times 6 isn't very useful is because the first thing I need to do is identify perfect squares. Because what I'm trying to do is make this a simpler version of a radical, or of a square root expression. So if I take, for instance, the number 72, there's lots of ways to multiply numbers together to get 72. There's 12 times 6, there's 9 times 8, there's 18 times 4, there's 36 times 2, there's 24 times 3. I can't think of another one off the top of my head. Are there? I don't know. You can think of one at home. But what I want to think about now is perfect squares. I want to find one of these numbers that's a perfect square. And I wrote the perfect squares over here. Perfect squares are numbers like 2 to the second power is 4, 3 to the second power is 9. All of these numbers in this column are perfect squares because you can take the square root of them in your head. And not only do you want to find a perfect square, like 9 is a perfect square, 4 is a perfect square, but I want to find the largest possible perfect square. And so in this case, it's 36. So I can rewrite the square root of 72 as the square root of 36 times 2, right? Because 36 times 2 is 72. But like I just showed you, you can split that into two roots like this. And then I can actually evaluate, rewrite as the product of two different roots and evaluate the root of the perfect square. So the square root of 36 is 6. And then I just have that times the square root of 2. I could prove to you with a calculator. I'm not going to, because I don't want to spend a lot of time on it, but these two values are the same. So the square root of 72 and 6 times the square root of 2 are the same thing. And we like this a little bit better because the square root of 2 is just a smaller irrational number. And so what we would say here is this is 6 root 2, right? That's sort of what we say when we see that. Let's do another couple here. So if I look at the perfect squares here, I think 25 divides into 50. So I could rewrite that as 25 times 2, or the square root of 25 times the square root of 2, and that would be 5 root 2. Let's think about 27. I think you can rewrite 27 as 9 times 3. 9 is a perfect square, so that's good. So that's the square root of 9 times the square root of 3, or we would say that the answer is 3 root 3. Let's do one more. 98 looks kind of scary until you think about the fact that 98 is actually just 49 times 2, and there's 49. It's the square root of, or it's 7 squared. So if I rewrite this as the square root of 49 times the square root of 2, that means that the solution is 7 root 2. This is just an important skill that you need, both when you get to Algebra 2, but also for the next video for lesson 6.2, which is about, 6.3 rather, which is about special right triangles, which you should go on to watch next.